Okay, so what is molar mass? Molar mass is the mass of 1 mole. So in your guided notes where it says molar mass, define it. It's the mass of 1 mole. Now, mass is just like, it's a scientific way of saying weight. So if you weigh 150 pounds, that's your weight. Weight is directly related to mass. They're not exactly the same, but they're very similar. That's a physics concept for you. And remember, a mole is just a certain number of atoms. It's 602 sextillion atoms. And I'm never going to quiz you on how many atoms is a mole. The molar mass is just saying, well, if you had a dozen eggs, how much does it weigh? Well, if you had a dozen ostrich eggs, I don't know if you've ever seen an ostrich egg, but they're giant, versus a dozen chicken's eggs, they'll have different masses. So the molar mass is just the weight of a dozen of eggs. But remember, it's not a dozen. It's not 12. It's 602 sextillion. So the molar mass is going to tell you how many grams 1 mole of a substance weighs. So if you found that 1 mole weighed 20 grams, or 1 dozen, say, weighed 20 grams, then we would say the molar mass, 20 grams, is 1 mole. So if you had 1 mole of something, it would weigh 20 grams, which is super handy for scientists when we're trying to talk about calculations and reactions. So how do we find molar mass? Well, this is just the Braintree periodic table, which you should have. So to find molar mass, we're going to look at the mass of the individual atoms and then add them up. So for example, let's say we wanted to find the molar mass of H2O. We've been talking about water a lot, and let's find the mass of it. Well, the atoms that make it up are hydrogen and oxygen. Now, we need to find the masses of the individual atoms, but notice we have 2 hydrogens and 1 oxygen. So we'll multiply 2 for hydrogen by its mass, which is listed on the periodic table. Here's hydrogen's mass, and there's oxygen's mass. I'm sure it's too small to see, so I'll tell you that hydrogen's mass is 1.01. That's what it says in that box. And oxygen's mass, in this box, it says 16. So if each hydrogen weighs 1 and each oxygen weighs 16, then what's the mass of the total compound here? Well, we have 2 hydrogens and we have 1 oxygen. So in total, 2.02 comes from hydrogen and 16 comes from oxygen. So the total mass, we would say, is 18 grams. 1 mole of water. If you were to get 602 sextillion atoms of water, it would weigh 18 grams, which is about 18 paper clips. It's like maybe 4 teaspoons of water is a mole, which is wild because if you had a mole of pencils, right, it would cover the earth. But if you had a mole of water, the same number of individual things, but atoms are so small, it only weighs 18 grams. So the mass again of 1 mole is just called the molar mass. And we found last time that the molar mass of H2O is 18.02. That's because we have 2 hydrogens and 1 oxygen. Every hydrogen has a mass of 2, every oxygen has a mass of 16, and we can look that up on the periodic table, add them together. We'll get 18 grams is equal to 1 mole. So 1 mole, if you had 602 sextillion atoms of hydrogen of water, that would weigh 18 grams. But this right here is an equivalency statement. They're equal to each other, so we can write 2 conversion factors out of this. I believe I'm highlighting it to point to the fact that it is an equivalency statement that we can write conversion factors from. And one of those conversion factors would say 18 grams of water is in 1 mole of water. What's the other equivalency statement that we could write? We could flip it upside down and say 1 mole of water is equal to 18 grams of water. Because remember, 1 mole is equal to 18 grams. We know that 1 mole is equal to 18 grams. So this is just like writing 18 over 18. 18 over 18, that cancels. This is just a really fancy way of writing 1 because they're equal to each other. And equivalency statements allow us to convert our units. Because we're going to do a practice problem. And that practice problem says, how many grams is 12.5 moles of water? So we're using those same dimensional analysis charts that we were using earlier in this unit, the same dimensional analysis charts that we were using earlier in the year, where we'd put the given in the top left and then the equivalency statement in the right. So in this problem, what is the given? 12.5 moles. So I'm going to stick that where given was. And you should also stick it down right underneath this over to the left. There's a yellow box for you to fill in. That's 12.5 moles. Now we need to use the equivalency statements that has the right units. Well, we're converting from moles. That's our given. We're converting from moles. So I need moles in the bottom. What am I trying to convert to? I'm trying to convert to grams. So I can just plug in my units of grams and moles. I need to know the equivalency statement between mass and moles for water. But luckily, we just wrote down those equivalency statements. It was the molar mass. And the molar mass of water is 18 grams. 18 grams of water is in 1 mole of water, or we could write it this way. 1 mole of water is 18 grams of water. So which one of these equivalency statements do we want to use? Well, we want to use the one that has grams in the top and moles in the bottom. Which equivalency statement has grams in the top and moles in the bottom? This one does. So I'm just going to plug in this equivalency statement, just 18 grams over 1 mole right there. So again, I matched the units. I want to convert 2 grams. I'm converting from moles. So I plugged in my equivalency statement. This is equal to each other. This is called the molar mass here. And so what does this exactly mean? That vertical bar means multiply. So you do 12.5 times 18.02 divided by 1. And I already did this for you. You get 225.25 grams. Why grams? Because the moles cancel out. You have moles in the top and moles in the bottom. So what I'm trying to tell you is that if you need to do a reaction, and in that reaction you need a certain number of water molecules. You need 12.5 moles, which is a ridiculous number of water atoms. But I mean, you drink hundreds of moles of water every single day. So you need 12.5 moles. And we need to know how much water to measure out. Well, every mole of water weighs 18 grams. And so in total, you need to start your reaction with 225 grams.